Okay. So let's talk about this device right here. This is called a wavetable, and it's kind of think of it like a slinky. But what I want you to do is I want you to focus on the little dots. On this side you see yellow dots. On this side over here you see the white dots, right?
Yeah.
So what I'm going to do here is I'm going to put a wave into this, and so you can see the different things that occur. So I'll start right here. I'm going to make a crest on this side, and it will travel down. Here, let's start it just like y'all did your lab. So one of the questions from your lab was, what happens if a crest travels down and hits a rigid barrier? What was your answer? What about you?
It reverses.
Comes back as a trough. So I'm going to put a crest on this side. You guys will see a trough on the opposite side.
Oh my god.
It comes back as the opposite, right?
That's
Okay, so now,
so rad.
what I'm going to do is something that you couldn't do with the slinky. I'm going to make another crest on this side, trough on that side, and it's going to travel down. So I want y'all to make a prediction. What will happen? Now it's not a rigid barrier that it's hitting.
Stop.
What's it going to do? What do y'all think?
Stop.
So it started as crest, you said it's come back as crest?
It's just not going to come back.
I hear somebody say stop. Okay, so let's take a look. Comes back on the same side. Again, that's because of conservation of energy like we discussed before. So what happens if I put this guy right here in the middle? So he's going to hold this bar steady. Okay? So this will be rigid. What do you think will happen? I'm going to send a wave down, and obviously if I send a crest down, what will come back? A trough. That's not so much what we're focusing on. My question is what's going to happen over here?
It's going to do
It's
nothing.
gonna switch.
Here you say go through it, or switch?
Nothing.
It's going to do
That's
nothing.
what
It's gonna keep going.
You say nothing?
On the opposite, no, it'll switch. It's on the opposite side.
Nothing.
So it's going to switch on the opposite side? Alright, y'all ready?
Yes. What did I say?
It doesn't go through. It's a rigid barrier. Right?
Interference.
Now,
See, right here, interference.
what I can put here, this guy, I can put water in. I'm not going to bother with that. I think it works pretty well just by itself. But this doesn't form a rigid barrier. Yeah, we'll start down here.
This is the worst.
Yeah, this is the wave. Alright. And so what this thing will do here is it's not a rigid barrier. So now, before we were talking about rigid barrier, that's like going from a wave going from like air to a rock. It's a very different medium, right? So now here I'm going from like air to different temperature air. It's a different medium, right? Because remember, the speed of the sound, or speed of waves in air, sound too, depends on the temperature, right? So what do you think is going to happen when it hits this barrier? Because this can pull this thing up, right?
It's going to become smaller.
Let's take a look here. So crest in.
Killed it.
It's hard to see.
It just
Kind of kills it.
It seemed
Let's try that again.
divine.
Crest in.
Nothing.
The crest comes back out, but notice that the energy is tremendously lower. You'll see that?
Yeah.
Right? So this kind of absorbs some of that energy. So again, I'll place this in the middle. And what do you think will happen?
Gonna kill it on the other side.
You should hold down the tooth. So it keeps lifting up. It's like messing it up.
I'm not so worried about that. So I'm going to make a crest here. So I want y'all to predict. What will happen on this side? Will the crest continue through?
It's gonna slow down.
It'll be really.
You think it'll be similar? We have a crest just smaller? Any other ideas?
Flip into a trough.
Maybe it'll flip through a trough? Right? Because before it didn't go through, so now it's not so rigid, so we'll expect something to go through. Now look at that. So we'll focus on this side first. So crest, still crest. It goes to almost, it's a little bit smaller, but it doesn't change very much. You have a question?
What makes it able to move like that? Like,
Huh? These things are connected here.
yeah, but which way?
Huh? Well, if you move this, it causes a torque on the next one, which causes a torque on the next one.
Make that.
But are they
specifically
on like a wire?
meant like is it string?
Yeah, this is one piece of material that has been cut. So it's one object, but it's just been cut with very thin connections.
It's like if you were to take a board and cut it in like
Yeah.
a little.
This
like something you could some
Oh, he's recording?
Yeah, let's grill some steaks up on that.
Why is he recording?
because I will post this online for people who are absent.
Oh,
Oh gosh.
Alright. So it's kind of hard to see what happened over here, but it was the same thing as it happened over here. That came back, but it was very, very small. Okay? And I can create standing waves with this, just like y'all did with the slinkies. If I create a very consistent pattern.
that's cool.
What?
So the thing I like about the wavetable, which is better than the slinky, is you see those dots. Those dots would represent an individual particle in that transverse wave, right? And so if you're measuring something, let's say amplitude, you're measuring from where the dot started to its maximum displacement in either up or down direction. I'll say that.
Yeah.
And I can increase my frequency. So any questions about this?